Hello everyone, this is Dr. Ali. And last session we started with recursion functions, and I gave you an introduction to Fibonacci series. And today we want to get a little bit more into the detail what is happening under the hood of this recursion function, and like the other issues or other problems that we solve. Let's look at the graph of this algorithm. We want to see what is the Fibonacci number or the value in the index 4. Okay. And we want to use this algorithm that I showed you last session. So 4 comes here and says 4 is not 1, 4 not 0. So call 4 minus f Fibonacci of 3 and Fibonacci of 2. So basically that's what happened here. That Fibonacci of 4, we don't know what it is. So in order to calculate Fibonacci 4, we need to know Fibonacci of 3 and Fibonacci of 2. And each one of them is again a call in the same function. Fibonacci of 3 will call Fibonacci of 2 and Fibonacci of 1. And Fibonacci of 2 here will call Fibonacci of 1 and Fibonacci of 0. And again, Fibonacci of 2, same thing happened here. And these leaves with the double circles here shows the base case that I showed you here. So now that we reached here, we know what is Fibonacci of 0, we know what is Fibonacci of 1. So we know how to calculate Fibonacci of 2. 1 plus 1, Fibonacci of 2, and we know that Fibonacci of 1 here was 1. So 2 plus 1 is 3, so we know what is the Fibonacci of 3. And then, now that we calculate this part, what is Fibonacci of 2? We need to know what is Fibonacci of these two, and these are base cases. So we already know these are 1. And then we have Fibonacci of 2. 2 plus 2 equals 3. And we have Fibonacci of 5. So this is how this algorithm is working. Now, let me actually copy paste the code for Fibonacci. I have it in my GitHub. I will share the link with you guys if you want to run it on your own. So if I, it is pretty much the same thing at this program here, but what I did, I just merged these two in the same if statement because both of them are returning 1. So I can just have a 1 if statement, and instead of returning like this, fn minus 1 and f minus 2, I just put them in two different, dummy variables, and then return t, which is the summation of t1 plus t2. The only reason that I did this because I just wanted to see what is the value for each one of these parts. That's the only reason. And if I run this now, let me save this. If I run it now. And if you go back here, so we can compare these two. One thing that I want you guys to notice is the order of execution of each one of these functions. So it's a tree. So first it wanted to calculate Fibonacci of 4, Fibonacci of 3, 2, 1, 0. So basically right now, the function is this will run, then goes here, then goes here, then goes here, then goes here. This is the line that so far starting from here to here, that is the path that the program actually followed from here, 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 here. And then when we have the value of these two, we have the Fibonacci of 2, which is 1 plus 1 is 1 plus 1 is Fibonacci of 2. And then we have Fibonacci of 1. Then when we have these two, we have Fibonacci of 3, this one. And then it comes to this path, Fibonacci of 2. Then Fibonacci of 1, Fibonacci of 0, these three, and then trace back Fibonacci of 2, which is the summation of 1 plus 1, that is this value, and then Fibonacci of 5, which is 3 plus 2. The sequence of how this recursion functions are running is very important. It helps you guys to understand what is happening really. So you see sometimes it's in traceback like here, sometimes in the actual calling the functions in the recursion manner. So this is important to actually follow this order. And just one question that I asked last session was, what if instead of two base case, we just have 1, right? This will cause an issue, and it become an infinite loop. And the reason for that is, imagine that we are in, let's say, Fibonacci of 1. We want to see what is Fibonacci of, actually 2. Okay, Fibonacci of 2 comes here, and you want to calculate Fibonacci of 1, because n minus 1 is 2 minus 1 is 1. So Fibonacci of 1, which is return 1. And what is Fibonacci of 0? There is nothing here, no base case, no return. So what happened? It will call this function again and comes here. Fibonacci of 0, we don't know what is, it's not a base case. So we call the same function again. Fibonacci of minus 1, Fibonacci of minus 2. You see, it will goes all the way to infinite, minus infinity. So it will never comes out of this program. That's why sometimes you need to know how many base cases you have. In this particular case, we definitely need to have 2 base cases. Otherwise, it goes all the way to the negative number and there is no return for negative numbers. And the program never comes out. So let me return it back to what it was. And that's it for today. Next session, we will see what are the issues with this recursive manner for solving some issues and problems. And it is really powerful, but it comes with a cost of response time or runtime and actually the memory. We'll see that although this is very powerful, sometimes we cannot even use it. So we'll see it in the next session. So if you have any comment or concern, please leave down below in the comment section. And till next session, have a great day.